Hi, everybody. My name is Jason Fraser. I'm a meteorologist with the NBC affiliate in Cleveland, Ohio, 3 News or WKYC television. So, today we're going to be talking about the sun. Why is it so important to Mother Earth? And how do sundogs and sun pillars and sun halos, how are they all created? But as always, I like to start off with something funny before we get into that. So, here's my joke for today. Why did the man use ketchup in the rain? Hmm. Three, two, one. The answer. Because it was raining cats and hot dogs. All right, I can hear all of you across the world laughing. Thank you so much for humoring me with that joke. All right, so as always, I love your questions. You can feel free to drop me a question or a comment right below this video, or you can feel free to email me at jfrazer@wkyc.com. That is jfrazer@wkyc.com, and I will get to your question immediately. So let's talk a little bit about this class and what we're going to be discussing today. So we're going to talk a little bit about what exactly is the sun. We see this thing every single day in the sky, but what actually is it? Why is it so important to our climate? And then we're going to talk a little bit about sun halos, sun dogs, and sun pillars. How are they actually formed and what are they? Obviously cool stuff. So let's first talk about what exactly is the sun. So the sun is a big, massive ball of gas. All right. It is really, really, really warm, and it is made up of about 91% of hydrogen gas. It's made up of a few others, but it's primarily hydrogen. Now, here are some pretty cool factoids about the sun. The sun is pretty old. We're talking about 4.5 billion years old. Yes, billion with a B. And according to experts, it actually has about another 5 billion years left until the star actually dies out. So the sun is actually the largest star in our solar system. And clearly, it is really, really powerful. So the sun does impact our weather a lot. And if we didn't have the sun, we would likely be in heaven right now. And that is because half the earth would be really, really warm, and the other half of the earth would likely be pretty cold. Now, the sun helps us a couple of different ways. Obviously, it helps us with light as the earth rotates, not only around its own axis, but around the sun. We get daylight and we also get night light, right? All right. It also provides for us some heat, which we're going to talk a little bit in a minute about how the sun actually provides heat to the earth. And it also contributes to the development of air masses and different temperature changes. Remember, we talked about what air masses were. That is where you have a bunch of air that has equal characteristics. So maybe it has the same temperature, maybe it has the same characteristics in terms of whether or not it's dry or whether or not it has a lot of moisture within it. Now, the sun is a pretty powerful thing in our universe, and it emits a variety of different types of energy. It's pretty similar to a flashlight. You know how you'll have a flashlight, and depending on how close it is to your face or your hand, sometimes you can actually feel some of that energy, some of that heat on your hand or on your face, or sometimes it'll actually blind you because the flashlight is so powerful. Well, that's essentially what is happening with the sun. Now, the first thing I'm going to talk about with the sun, that the type of energy that it emits is something called infrared radiation. It's basically a fancy way of saying it is the heat energy that we feel. So when you go outside and you put your face like this and you feel the sun on your face, that is infrared radiation. Now, depending on how much of this radiation is going on, sometimes it can lead to what we call cloud development, right? Which is essentially where you have a lot of energy that comes in from outer space, you get a lot of heat on the ground, and that heat rises. And sometimes it'll actually form clouds. Now, the really cool part is sometimes originally there might not actually be clouds there. And then after the clouds develop, and sometimes you'll actually get some of that energy that ends up being stuck on Earth because it's trying to get back into outer space, but it hits the clouds and it just goes back down to the ground. That's why sometimes at night it's still pretty warm because all that energy hasn't left. Now, it also works the opposite way, right? So on a very cloudy day, you can have energy coming from space and it's actually blocked by the cloud cover. So that's why even sometimes on a really cloudy day, it might be a little bit cooler as well. That the sun emits is something called visible light. Now, this is the light that you can see with your eyes, right? Sometimes you'll actually see this light during the day and it looks really white. Sometimes you'll actually see it and it looks yellow. It really depends on what time of the day that you're looking up at the sun, which you shouldn't be doing, by the way. And if you are doing it, you should also make sure that you have the right protective gear on your eyes. But this is what we call visible light. There's one more type of energy that the sun emits that we can't see. It's something called ultraviolet light or UV light. It's one of the things that maybe your doctor or your parents have talked about. That's the energy that can burn us, it can cause us harm. It hits your skin, and then sometimes it'll actually force it to turn colors. Sometimes you could potentially get some sunburn. And that's the reason why we highly recommend that you use sunblock, particularly during the summer months. Now, that leads me to another thing. If you are outside, sometimes when you look up at the sun doesn't always look circular. Sometimes there are things that look like they're kind of around the sun, right? So, depending on what it actually looks like, is how we as scientists define it. So, sometimes you'll see this little ring that goes fully around the sun. And you might think that maybe aliens are coming. I promise you, they're not coming. It is something that we call a sun halo. And it is a ring that forms right around the sun. And it actually happens because of the clouds that are in the sky, particularly cirrus clouds. What happens is you have sunlight that is actually radiated off of that cirrus cloud, and it looks as though there's actually a ring right around the sun. Actually happens at night too. On a very clear night, sometimes at the ground, you can actually see what we call moon halos. And when I say clear, I'm going to put that in air quotation marks because, again, you need those cirrus clouds. But when I say clear, I'm referring from the ground because some of those cirrus clouds have to be way up high in the sky in order for that light to hit those cirrus clouds and reflect and basically make a halo. Then we have something called sundogs. And you might have seen this. Sometimes this will actually happen either during the sunrise or maybe you'll be driving down the highway and you'll actually see these two things. They almost look like bodyguards around the sun. No, the sun does not have bodyguards. Okay. It is what we call a sundog. And usually what will happen is this often occurs at 22 degrees to the west and to the east. All right. So if you think of a compass and you think of east and west, if you're perfectly looking at the horizon, at the sun, you'll notice that. All right. And the reason why that happens is, again, because of those ice crystals, how that light is hitting the earth and how it's hitting some of those clouds, which are ice crystals, and it reflects back. It's also really cool. And I want to show you just a bigger picture of what it looked like there. There you can actually see how at 22 degrees, there's one of those ice crystals that's appearing right there. And there's another one that's appearing right there. Again, 22 degrees is what you need in order to see those things right around the sun. Then, which are something called sun pillars. All right. And sun pillars, basically, it looks like the sun is almost touching the heavens, it's touching the sky. But the interesting thing is, well, the sun is in the sky. So how can something that's in the sky look like it's actually touching the sky? Well, what happens is the light is actually moving vertically. And this is, again, all because of ice crystals. That light hits the ice crystals and it makes this thing that looks kind of illuminating. It looks pretty cool. Now, this usually happens during sunrise or sunset. All right. And a lot of this has to do with something that we call sun angles and where you are in relation to those sun angles. And that's something I'm going to discuss in our next lesson. All right, so that lesson went by pretty quickly. So we learned a few things about the sun and how it impacts our climate And then we learned a few different details about the sun. So tomorrow, we're going to talk a little bit about the sun as it relates to sunrises as well as sunsets. How do we identify what those are? And what exactly are they? We're going to talk a little bit about sun angles and why at certain angles the sun setting looks a little bit different from where you are versus where somebody is 100 miles away. Why do the sunrises sometimes change color? Something that I've always enjoyed actually watching, especially my wife too. She loves the sunrises and sunsets. As always, any questions, comments, concerns, you can feel free to tag me on any of the major social media platforms on Instagram, Facebook, Twitter, as well as Snapchat at Jason Fraser TV, or you can hit me up via email at jfrazer@wkyc.com. I hope that you learned something throughout this lesson. And if you are watching this on Facebook, I want to let you know that it will automatically post here on this page within 5 minutes. So you can just hit the refresh button and you should be able to start this lesson again. You can always go to our website, wkyc.com/education, and this lesson will appear there as well. Have a wonderful day, and I look forward to seeing you next time.